usually it's when we're in complex numbers, if we were given a root that is a complex number, but the coefficients were real, which in this case it isn't. If the coefficients were real, then we could have said, if I is a root, then negative I is also a root. Right? You with me? Usually. The reason why I say usually is because that's what a lot of students would usually do in these questions. It's wrong because they're not real coefficients. So then you ignore that idea, you go to your secondary idea, which means if something's a root, what do you usually do? Just sub it in. I, sub it in. I squared plus IZ plus 2 minus I must equal to 0. Something's a root, just sub it in. I squared is negative 1. Negative 1 plus 2 is 1. 1 minus I plus IZ is equal to 0. IZ, what am I doing? No. I got it from here, but you meant to say, where did I get the Z from? Ki, there we go, that's better, equals 0. Yes? Now I see a little problem, so just give me a second to think about this. What happened there? I squared is negative 1. Negative 1 plus 2 is 1. 1 minus I, Find the complex number k, given that I is a root of the equation. I know what I should be doing, but it shouldn't work. It doesn't work. So 1 plus I, k minus 1 equals 0. Find the complex number k, given that I is a root. Secondary ID, that's what I was going to say. Secondary ID. It's not working out, unfortunately, so let's go with the next one. Alpha plus I must equal to negative k. Negative k. So therefore, alpha is equal to negative k minus I. And that's your next root. Find the complex number k, though. You haven't found k, actually. What's wrong? Why is this not working out? Let me just go back to basics. Give me a second. Give me a second. Give me a second. Give me a second. Let me just think what I'm doing. Z squared plus kz plus 2 minus I. If I solve it, I'll work out z, which means I'll work out both roots. But when I solve it, I'll still have k's, which means I can't solve it. So that means, given that I is a root, it should just sub it in, which I have. But if I just say k minus 1 is equal to, something's weird. What is weird? It's so basic, I don't even know what's happening. Okay, let's start again. Let's see. Let's have a look at quickly at the answer. Oh my god. Find the complex number k, given that I is a root. It's such a simple question. Definitely caught me off guard with that one. I have no idea where I'm going wrong. Question 2. Let's go up. Question 2. Okay, one more time. K is equal to negative alpha plus beta. Negative, yes, yes. 2. Okay. So I should have just continued. Okay, let's start again. Fair enough. I underestimated the question, I guess. My bad. I really thought it was just going to be a simple substitution. Let's start again. Sum of roots one at a time. So your roots are alpha and I. Sum of roots one at a time. Alpha plus I is equal to negative k. Product of roots. Alpha I is equal to minus BC on A. 2 minus I. Alpha is equal to 2 minus I on I times by conjugate, which is negative I. Still with me? Equals negative 2I. Negative I is plus I squared, which means minus 1, on negative I is negative I squared, which is actually 1. Now that you found what alpha is, so you found the third root, or second root, sorry, we're going to sub that second root into this formula here that we have for alpha. So alpha is negative 2I minus 1 plus I equals negative k. Negative 2I plus I is negative I minus 1, which equals negative k. Therefore, k equals to I plus 1. Really underestimated that question. I guess if I was studying, you're right, I wouldn't have underestimated. I would have done everything. But like you said, some of it, I just decided to stop because I really thought it was still just going to be a simple substitution. So that's okay. That's all right. All right. What's the next question? 3 double I. No more underestimating. That should be properly. All right, 3 double I. Plot. Oh. Did you work out your find ZA? You found that, which gave you negative 1, I'm guessing. Yep. Plot on the algorithm diagram all the complex numbers that are solutions of ZA equal to negative 1. Now, okay. So Z8 equals to negative 1. You realize that Z can equal to cis pi on 8, right? You know what the modulus is. The modulus is obviously 1. Yes? So I don't know if you guys have linked omegas and these just yet, because we only did it last week. But there is a nice relationship when you factorize this as well. But we won't get into that. I'll do it the way I think you guys will be okay with, guaranteed. So we're going to solve for all our Z values. To solve for our Z values, we know they have to be in Z equals R cis theta form, where we know R is equal to A to the power of 1 over N, and theta is equal to 2k pi plus 5 over N, where A is this in mod arg form. So let's just say this would be 1 cis pi. We're okay with that? 100%? Okay, then this one's just 1. This one is 2k pi plus pi over 8 for k is 0 all the way to 7. So the first one you would get is obviously 1, so we're going to ignore the 1. Cis pi on 8. Right there, as we know. Next one you'll get is 1. 2 pi plus pi is cis 3 pi on 8. 2. 4 pi plus pi is cis, and I think you guys can probably see the answers by now. It's gone up by 2 pi. Right, which you should, it will always be doing that. Because you're always just going to add an extra 2 pi to anything you have. So cis 7 pi on 8, that's 1, 2, 3, 4 solutions. 5 solutions, and I think you guys get the idea. Right, Mariette? There you go. That's 8 solutions right there for my 8 Z values. Question says now to plot it. Well, very easy to plot because you know the modulus of this whole thing, which is just 1. So you know it's going to be on a unit circle, which is really bad. It's going to be on a unit. Oh, I can't get that out. Let me start from there. There we go. There's my unit circle. First one is at pi on 8. How big is pi on 8? Grab your calculator. 22. 180 divided by 8. 22.5. So there's the first one. That's Z1. Z2 will be 3 times 180 on 8. 67.5. Z2. Z3, 5 times 180 on 8. 112.5. Z3. Z4, 7 times 180 on 5. 252. 7 times 180 divided by 5. 157. I thought so. Somewhere there. Z4. Z5, Z6, Z7, Z8. That would be all your 8 solutions on Eigen diagram. Any questions? Happy? Happy. And if you want to check something, this 15 times 180 divided by 8, take away 360, gives you negative 22.5, right? So this becomes cis negative pi on 8. Can you see? They're in the same x value, just different y values. Maybe can you see that? To Z1 and Z8, yeah. And you guys know that happens. Whatever. Sounds good? So if I was, I should have been a little bit more accurate, but I think you guys understand that. Any questions? Any more? Anything else? Nope, that's it. Phoenix done? Phoenix done. Close it up. Oh, well, we'll have to get homework, so we'll leave that. Let's go to this year's paper. It was easy. I think you guys have heard that, maybe from other people. Yeah. It was probably the easiest paper out of all 4, which is good. But I'm not surprised by it, because that's how Extension 2 is. What you got to remember is Extension 2 is a 1-year course, not a 2-year course. The reason why Extension 1 and Advanced was really hard, 30, I think we counted 39 marks in the Advanced paper was from Year 11. That's a lot. More than what it's ever been. 39, that's 40% what was just Year 11. Which is just ridiculous. So that's why people found it hard. They found it hard because it wasn't calculus that was the problem. Year 12 was the calculus bit. That's easy. It's the Year 11 stuff that they stuffed us in. So I'm doing the right thing by doing a prelim a week. That will be fine, but you got to remember it's Year 11 that would be bad. Year 12, Extension 2, like I said, whatever you learn, like you guys have learned all this, you're going to see it again. It's not bad, actually. So, anyways. Rewarding to those who did Extension 2. Let's have a look at it, and you can tell me. That's part of vectors. You probably have forgotten the formula, but it's actually very easy. Probably because when you were learning it, you were everywhere. But it's just Pythagoras. Pythagoras, by how many terms you're going to have? 3. So it's just 1 squared plus 18 squared plus 6 squared. How easy, right? Seriously. Done. Anyways, you're more interested in question 2. Given that z equals 3 plus I is a root, what are the values of p and q? I think you guys know what you've got to do, right? P and q are real. They tell you that. So if 3 plus I is a root, what do you know straight away? 3 minus I is also a root. Why are you being slow? Don't be slow. Don't be slow. Straight away. If you know your stuff, you go straight away. Z conjugate equals 3 minus I is also root. And then obviously what are you going to do right after that? Sum of roots, product of roots. I would have said sub it, but you're going to find P's and Q's. You might as well go and find sum of roots, product of roots. Go. Let's get question 2 out. use the formula, right? The formula over 2 a plus b. All right, what did you guys get? 3 plus I plus 3 minus I is equal to negative p. 3 plus 3, so p equals to negative 6. Yeah? No? Maybe? I'm confused. Ben, talk to me. What's happening? 3 plus I, 3 minus I is equal to q. 9 plus 1. Q equals 10. Remember, it's multiple choice, so no one cares about you working out, but whatever. I know, all good? Done? Move on? Move on. What is the Cartesian equation of the line? Again, you guys probably just don't remember it, but it's just y equals mx plus b. Anyways, move on. Ooh, fancy. 4. Diagram shows the complex number z on the Argand diagram. It's somewhere there. Which of the following diagrams best shows the position of z squared on modulus of z? Interesting. So just pause for 2 seconds. Z squared. What does z squared mean? Well, z squared means if z was x plus iy, square it would mean x squared minus y squared and then plus 2xyi. True? See how quickly I jumped into that? I didn't look into it too much. Over. What's the modulus of z mean? Square root of? Good. Then it says, which of the following diagrams best shows the position of this? Well, you now know. Look, how can I show it to you? If for any reason you couldn't do it the way I'm doing it now, pick a number. Like this could have been 2, and pick this as 3. So 2 plus 3i, actually. Let's just do that. Maybe that's safer for now. 2 plus 3i. So when I square it, I'm definitely going to get 2 squared minus 3 squared plus 2 times 2 times 3i on square root of 2 squared plus 3 squared. Is that cool? So that means you would have ended up with 4 take away 9, so negative 5 plus 2, 4 times 3, 12, 12i over a positive number. It doesn't really matter, like let's just say square root of, what is it? 13, 5, square root of 5, it doesn't matter, whatever. 9 plus 4, 13. But yeah, whatever. So essentially, it's saying it should have been a negative x value, unfortunately, plus a positive y value. If I had chosen 2 and 3. So negative x and then positive 12i on root 13, so somewhere here. The problem with that is it's because I chose 2 being smaller. That's an assumption that I chose here. The idea is, how would you have known 2 smaller than 3? What if it was 3 is meant to be, what if this number was meant to be larger? Right? Which it usually would be if you can see the x value of this should have been larger than this. Because that answer won't work. Sorry, that answer won't work. Definitely. We know that. Yeah. So you can tell it's still in the first quadrant. I think the question that you want to try to raise here is which one of these? Is it still going to be on the same unit circle? Here, I'll quickly change it again. I'm just doing this as a very poor way of doing it. That still doesn't change. That doesn't change. There we go. So now that all of a sudden just becomes a 5. Can you see all that happened? I just changed my x value, made that larger, y value, you still got them as positive. Now what you're asking yourself is, where is 5 on root 13? Where is 5 on root 13? 1.3. So the x value is at 1.3, the y value is at 12 on root 13, 3.3. So the x value got smaller, while the y value got larger. The x value got smaller, whereas the y value got larger, and the answer should have been B. Let me confirm it. I did write the answer to this, actually it should be B. I know it's B. So if for any reason you couldn't do it algebraically, now x squared minus y squared on square root of x squared plus y squared plus 2xyi on square root x squared plus y squared. Comparing that to x plus I y. Okay. No, it's going to be too hard to explain like with that. Let's do it numerically. I'll show you the proof of this. I think that's going to be better. I'll show you guys the proof of that and what happens to that. Maybe that's a good note for me to make right now. Let's go through theory of complex. Something we've been talking about. Theory. Got it. Next. Keep going. Particle. Which expression? Oh, there you go. That's something you guys can definitely do, right? What method do you use for this one? Completing the square, 1 over x plus 2 squared plus, that's 4. 4 plus what gives you 10? 6. Now you know that's an inverse tan, and with inverse tans, I think it is 1 on A. So 1 on root 6, inverse tan, x plus 2 on root 6 plus c. Again, you wouldn't write it all. Once you know the answer, you're just going to go for A. Right. But yeah. All good? That's part of proofs, not for us. What is the maximum value of EI theta minus 2 plus EI theta plus 2 in modulus? Now, EI theta just means cis theta. Right? So a little bit of a trickier one. A few ways around it. When it's saying what is the maximum value, it's essentially trying to say this. Well, comes back again to the theory, but hold on. Maximum value. For example, if I had, I don't know, a circle like that somewhere, this would be the minimum distance. The maximum distance would have been that one there. Can we see that happening? That would be the max value of the distance when saying modulus. What do you know about modulus? What was... Again, I probably skipped through this with the theory, but it's okay. If I said modulus of A plus modulus of B, do you remember that it became the modulus... Wait, am I thinking of conjugates? Hold on. Ooh. Yeah, definitely conjugates. Sorry, wrong ones. I'm thinking of conjugates. Do not mix that up. Right? Modulus of A plus modulus of B is not the same as modulus of A plus B.
Isn't it times when you add the arguments?
Yeah. Sorry?
Or isn't it E times the modulus when you add the arguments? Is it E?
That's in polar form? Yeah.
Okay.
So EI theta minus 2 plus EI theta plus 2. I guess EI theta minus 2, if you wanted to, you can convert it to cis theta minus 2, find an argument, find the modulus of that. So that's cos theta plus I sine theta minus 2. Find the modulus of this. How do I find the modulus of this? It's the square root of cos theta minus 2 squared plus sine squared theta. You guys with me? Plus square root of cos theta plus 2 plus sine squared theta. Expand this, cos squared minus 4 cos plus 4 plus sine squared plus blah, 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 plus sine squared. Cos squared plus sine squared is 1. 1 plus 4 is square root of 5 plus 4 cos theta plus square root of 5 minus 4 cos theta. I'm going about this the wrong way again. 5 minus 4 cos theta. What's the maximum value that cos theta has? What's the maximum value that cos theta has? Think of the graph. What's the maximum value that cos theta has? 1. So cos theta is between -1 and 1. Now we know that cos theta cannot be, we cannot get to the negative region. We cannot get, to this region. Because that would mean that you would have a negative y value, which you can't square root. So it's actually between 0 and 1. Does that make sense? So 0 less than or equal to cos theta less than or equal to 1. Times everything by 4. You would get 0 less than or equal to cos theta less than or equal to 4. -4. Plus 5. 5 less than or equal to 5 plus 4 cos theta less than or equal to 9. Getting there. That should have been a negative, right? Because it's going to be -4 cos theta. Square root of 5 less than or equal to square root of 5 plus 4 cos theta less than or equal to 3. Still with me?
Yeah.
You sure? All right, let's go back. This is question 9, by the way. Question 9 is just meant to be the hardest one with question 10. But question 10 was actually really easy, which is weird enough. But anyways, let's go back. Let me start again. Let me think of a second method if I can think of one at the same time. Secondary method of doing this question. Secondary method. Did you understand it all up to here? Did you get it all up to the stage that I even wrote square root of? Say it again. I lost you there. Oh no, that was okay.
When you started writing the domains,
So square.
you lost me.
Yeah. Okay. Let me think of a different version. Modulus. Modulus with exponentials. I'll give you a different version. Different version. Can I give you a different version? I'm thinking. Let me get back to it. I'll try to see if I can think of a second method. Let me get back to it. But anyways, with that one that I was doing, if I finished it off, I did 5 plus 4 cos theta. If I did the same for 5 minus 4 cos theta, added them together, the maximum values would have given me, I can't even remember, but I think it gave me 4. So 3 plus 1 would have given us 4. Because minus 4 plus 5 would have given you 1, 3 plus 4. Yeah, but it's okay. I'll think of a second method. I'm sure I can think of one. I just can't remember some of the properties of complex here. But let's I'll come back to it. Question 9. 10, we can do it, but I haven't gone through the theory of integrals either. That's part of the reduction formula stuff that we just paused. I didn't do too much reduction formula, so we won't do it right now. We'll keep going. Those are your standard 3 markers. I'm not going to do them because I think they're easy. Use integration by parts. That's one that we've seen 1,000 times by now. X log x, another easy 3 marks. Find an expression for x in terms of displacement, in terms of v. Very easy. You're just going to use dv, v dv on dx for acceleration, and then you're meant to just integrate. So easy 3 marks. Prove that these are perpendicular. I don't know if you guys remember this, but perpendicular, what we did is we found that the dot product equals to 0, and that's it. So, and the dot product was just the first 2 multiplied plus next 2. Very easy 3 marks. Let's do the 4 marker, because that's something you guys can do and should do. Solve z squared where a and b are real. What's going to happen when you're going to solve this? What's going to happen eventually? What are you going to first use to solve it?
X plus R.
No. Not completely square. Quadratic formula. And then within that quadratic formula, what's going to happen? Think of the stuff that you've done in complex numbers. I think you're saying it wrong, but you're saying the right thing, which is weird. What's going to happen is you're going to get the surd. You're getting a complex number inside your surd, inside your square root. And then you have to do the whole equals to a plus ib, do that stuff. You remember how you have to find square roots of complex numbers? That's why it's worth 4 marks. Otherwise it would just be worth 2 marks if it was a simple solve. Just go ahead anyways. Quadratic formula. Matt, you got a question for me? Okay. Mm-hmm. Yeah. 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 You should get 2 solutions for Z. X plus IY squared. No.
2 plus 3 back to
Let's see what you've done. You guys should do the correct formula, right, Stefan? What did you get when you do the quadratic? Come on. Sure. Append. So solve z squared. Yeah? Tell me. Z equals minus b plus minus square root b squared minus 4 times a times c all over 2a, which equals negative 3 plus minus square root 9 take away 12 plus 4i. Does this look right so far? Okay. So then we end up with this. Negative 3 plus 4i over 2. Is that right? And then you make this bit here equal to your a plus ib, and then you do whatever you got to do. Or is that, have you forgotten how to do that again? Forgot? Okay, so at this stage you'll write root negative 3 plus 4i equals to a plus ib. Then you would square it. Then you would expand. Now I'm sure you guys can continue from there. Am I right? Equate, real, imaginary, go. Alright, what did we get now?
just asking for
Okay. Yep. Good. Next booklet. Next booklet, if you like. You go find out. Okay, what do we get for A and B here, you guys? A is 2, B is 1. Let's see if you're right. 1 take away 4 is negative. I think you're right. Negative 1, and then what, B is negative 2? Yeah. Yeah, it works. You're right. A is 1, B is 2. Yeah, I'm happy with it. What about you guys?
Yeah. But then I found the root.
No, I know, no, that's not done. A is 1, B is 2. That means, therefore, Z equals negative 3 plus minus A is 1. 1 plus 2I. on 2. True? A is 1, B is 2. Therefore, you just get plus minus 1 plus 2, right? What's up? Tell me.
Are there n equals b squared?
Say it again.
M equals b squared.
M equals, what's M?
Well, I don't know.
Where are we getting M from? Wait, I'm confused. Hold on. Oh, that. I don't think we need to do it like that. We need to do it like that.
That's what I do.
You just did it as a quadratic, like it's fine. B4 plus 3 is good. Oh, things are not in the right order. You've written a constant, and then your B4 and your 3B squared there. That's your A, that's your B, that's your C.
Yeah.
Doesn't mess it up.
That's
B,
what.
yes.
That's all.
Ugh. Yeah. Yeah. Hold on. What I'm saying, Mariette, is you've written this. A squared minus B squared negative 3. 2AB equals 4. B equals 2 on A. You subbed it in. You worked out that it became 4 on A squared. Sorry. A squared minus 4 on A squared equals 3. Then you work out this. A4 take away 4 equals 3A squared, and then you're changing the A4. Why? You know it's a quadratic. So why don't you just assume that that was just like nothing. Just go A squared equals and then solve it. Minus 3A squared minus 4. Just go A squared equals instead of changing for M. Because you know that that is your A, like X, isn't it, technically? You get what I'm saying?
Yeah.
Like it's a quadratic anyway. So A squared equals, or factorize. Oops, equals 0. So A squared minus 4. A squared plus 1, which is the one you had. So this one's wrong. The other one you're meant to have was A squared equals to 4, which means A equals to plus minus 2. If A equals to plus minus 2, how come you got other way around? But I know your way is right. The reason why I know it's right is because it should have been 2 squared take away 1 is 3. There should have been negative 3. So where did I go wrong? 4 divided by 2 is 2. 2 on A, subbed it into B, which is 4 on A squared. A4 minus 3A squared minus 4, this guy. Minus 4 plus 1 is minus 3. That's still minus 4. Whoa. I don't even see a mistake. A should definitely be 1, right? Is that what you guys got?
Yeah, I just looked at it.
All right, let's just start from the beginning. You're killing me, you guys. Let's go again. Z squared plus 3Z plus 3 minus I. Z squared plus 3Z plus 3 minus I equals 0. Here we go. Z equals minus B plus minus square root B squared minus 4 times A times C all over 2A. Negative 3 plus minus square root 9 take away 12, negative 3 plus 4I over 2. Any questions at this stage? Root negative 3 plus 4I equals A plus IB. Square it, negative 3 plus 4I equals A squared minus B squared plus 2ABI. Negative 3 equals A squared minus B squared, 4 equals 2AB. B equals 4 divided by 2 is 2 on A. Subbing B into this, I get negative 3 equals A squared minus b squared. Any questions at this stage? This becomes a squared minus 4 on a squared, multiply everything by a squared. Ah, that's where it is. That should be plus 3. All right, doesn't matter. Negative 3a squared equals a to the 4 minus 4. Bring everything, I get a to the 4 plus 3a squared minus 4 equals 0. I was saying why you can use substitutions and stuff, you know. Just either go a squared equals and do a quadratic formula again, or I can just see I can factorize it. A squared plus 4, a squared minus 1. A squared equals to 1, which means a equals plus minus 1, which means b equals, go back up here, plus minus 2. So then, go here, and I go negative 3 plus minus. Instead of it being this, it's a plus ib, so plus minus a plus ib on 2. And then we should be done from there. Now, why are you guys still doing all of this? Told you last week or the week before, whenever it was, so you can do it through observation. So you should have asked yourself 2 times what 2 numbers would have given me 4? 2 and 1, right? Then you would have gone and checked it. 2 squared take away 1 is 3, not negative 3. It means swap the order around. A should have been 1, B should have been 2, finished. It could have been finished. Keep that in mind. Don't feel like you've got to do all that math. Done. Cool? You guys still got to work on that. If that's not perfect, already week 4, week 5, it has to be. Don't have much time left for it. Make them perfect. Open up every exam paper like I keep doing. Just keep going through it and revising again and again and again. Easy. That won't even be a problem. It was part of 3 unit. That's probably why we found it all easy. Extension 2 had 2 topics that they took out, conics and volutes. And they didn't replace it with anything. They just took it out. And that's good. And this was all 3 unit. They got brought up to 4 unit. So, I don't know. It's easy. That's all I can say. But anyways, whatever. Again, projectiles, for those who are doing physics, like seriously, show that this Cartesian equation, like that's like day 1. That's exactly what we're going to do in day 1. And say, hey, just do this. I don't know. We're thinking, I don't think it'll be asked again. So I don't think your year, it's just going to be like, do this. Because that's straight through unit. There's nothing to it, which is weird. So your one's probably going to be applied. That's how I'm going to take it. Simple harmonic motion, again, straight from 3 unit. So all easy. And look, there was that question. That one, the one we know how to do. I hope we just do a minus b squared greater than or equal to 0. I don't know, this time I think they tried to do it by considering writing the triangles to hopefully confuse some kids. But we would just do it otherwise. A squared plus b squared greater than or equal to 2ab. And then I think you guys know we replaced a squared for a, or x. A squared equals x, b squared equals y. Therefore, you just proved x plus y is greater than or equal to 2 root xy. Very easy, yeah? And then do the same thing again. I think you know what b got replaced for. What's b equal to? Technically, look at it a little bit more. No, a little bit more. Yeah, I would have said b is equal to 4q squared. A is equal to p squared. And then what's the square root of 4? 2. But then 2 times 2, this 2 gives you that 4. And that's it. $30. Am I saying it's too easy and it's not easy? Or you guys realizing, hey, it's easy. Okay, that's really 3 marks, nothing. Show, that's the one I really want. Because that's our trig stuff. Can you see it? Trig. Instead of it being cis, though, they made it exponentials, which I'm assuming means they don't want cis. They want it as exponentials. Fair enough? So we're going to try to use exponentials as much as we can. But anyways, the weird thing is you need to use cis anyways. That's what I said. I think when they changed the syllabus, they didn't realize that you still got to use cis. So they didn't make it flawless. All good. Show this. All right, what do we know EI theta is? EI theta also equals to? Just this theta. Yeah. No R because there's no R in front of this. There's no number in front of this. Right? Yeah. EI theta is the same as cis theta. If there was a modulus, there's a modulus here as well. The only difference is the E and the C and the S. So we get cis theta to the power of what? N plus cis theta to the power of, and hopefully if you do it right using who? De Morey, this becomes cis n theta plus cis negative n theta. What's cis n? Cos n plus I sine n plus, what's cos of a negative? Cos, good. Cos n theta. What's sine of a negative? Negative I sine, and what happens? What do you get? Easy 1 mark. Boom.
You have to state by the line.
Okay. HSC, no. Your school teachers, I don't know. The problem with your school teachers is a lot of them are not Extension 2 qualified, right? So they haven't taught Extension 2 for more than 5 years. That's what we're going to say qualified. So therefore, they're going to follow the marking guidelines. When they follow the marking guidelines might say by De Morey, and if they see that it's different, they just have to mark you wrong because they don't know that you don't need to write it. So I don't know. Your school teachers are a bit tricky. But we can always argue, because that's when you bring it to me, I'll just press Control P, I'll give them the marking guidelines from another HSC paper, which will be fine. Does that make sense? But it is what it is for two teachers. When you do that, just tell you the same question you just asked, record it, so in case they say yeah, no, and then later on they say yes, or whatever, and that's it. All right, by expanding to the power of 4, I think you know what that means, yeah? That means essentially, do this, do that to the power of 4, which is itself to the power of 4. So that just becomes 2 cos to the power of 4 theta. But also you've got to expand this to the power of 4. Let me do it. So now we know EI theta, what was it? EI theta plus E negative I theta is the same as 2 cos theta. Would we agree to that? I'm ignoring the n. I'm ignoring the n because this doesn't have an n. True? I'm ignoring the n because this does not have an n. All right, and then it says power of 4. There it is. Power of 4. There it is. You'll see how to use this n in a second. This becomes 2 to the power of 4, which is 16, cos to the power of 4 theta. Let's go look up again. Cos to the 4 theta, exactly what I want. Then it's saying these ones going to be multiple thetas. We'll see in a sec. This side. This side we're going to expand using binomial. So it's going to look like this. E 4i theta plus 4e 3i theta e negative I theta plus 6. Is it 6? Yep. Right? 1 plus 3, 3 plus 3, yeah, 6. E 2i theta, everyone's with me? Plus 4e I theta e negative 3i theta, and last one is e negative 4i theta. What's wrong? I think you're thinking of the second version of tree. There's two versions. The one that we probably did a lot more of, which isn't this one, is the by de Moivre, by binomial, expanded, and then equate real with real, imaginary with imaginary. Is that the one you're thinking of? This is a different one. There's two versions. The first version is that one there. That is multiples in terms of powers of trig. Right, the powers of trig. This one's what? Power of trig in terms of multiples. Can you see how it's multiples? 4 theta, 2 theta. Second version. So again, now that you guys said that, with those faces, revise second version of trig. Understand what that is? Keep going. Then group this and this, e 4i theta plus e negative 4i theta. This becomes 2 with this guy, becomes negative 2. So it becomes plus 4 e 2i theta plus e negative 2i theta. These two just cancel out, you're left with plus 6. What did you just prove above? You proved e n I theta plus e negative n I theta is 2 cos n theta. So what does this straight away just become? 2 cos 4 theta. What does this become? 2 cos 2 theta plus 6. Do you get that? No? This e 4i theta plus e negative 4i theta, isn't it the same as this? E 4i theta. So you just replace the n now for 4 theta. That's why I said group it in pairs. So those two are going to become 2 cos 4. These two, negative 2 and positive 2, become 2 cos 2 theta. Where did negative? This one right here. Right at the end. We'll do it, maybe we'll even do it today. Now that I realize that's a weak one. It's okay. I'll show you where it is as well in your booklets. 2 plus 8 plus 6. And then I think you guys know what I'm going to do with my last line. The question said to prove just cos, not 16. So what am I going to do with this 16 that's here? You're going to divide it. 2 on 16 is 1 on 8. And I think you guys can see the rest of the answers. So I'm going to divide by 16. That's going to give you 1 on 8. 8 on 16 is half. 6 on 16 is 3 on 8. And what they did, if you want to look at it, 3 on 8, they just times this one by 4 to make it on 8, right? Let me make sure. Yeah, times it by 4 to make it 4 on 8, which is a half. All right. That would have been done. 3 marks. We're going to do it again. Don't worry. We'll do it again. It's okay. We'll start again from the beginning. You'll see. You'll get it. It's different to the other version. The other version everybody gets. The equate real and imaginary. This one here, because it's not asked as often, most students forget about it, maybe even forget about studying it and never know that. But at least gave us a good reminder. There you go. All good. I'll go through it. And then the next 2 marks was really easy because all you had to integrate was this, right hand side. And how do you integrate cos? Positive sign, yeah, you're right. And it's just sine 4 theta divided by 4. Sine 2 theta divided by 2. And you're done. Plus 3 theta. And then subbing pi on 2 and 0. Easy 2 marks, right? So that integral question wasn't too bad at all because I gave it to you. Okay, let's try this. You should be spending all of your time doing exactly what I'm doing for you right now. Just open up the HSC paper and attempt every question. If you can't do a question, look through the solutions. If you don't understand the solutions, try to persevere and try to understand the solutions. And if you absolutely can't, that's when you should ask.
Solutions.
Yeah, not for the 2020, like 2019. So. There'll be up solutions, I think next year. But I'll give you mine.
There's a number of Facebook discussion page for whatever, and someone like choose put it up.
Yeah.
So they're very long.
Yeah. Usually I got mine done that day. So, but I can give it to you if you want the solutions to these. Let Z1 be a complex number, let Z2 become EI pi on 3Z1. Diagram shows points A and B which represent Z1 and Z2 respectively in the Argand plane. Explain why triangle OAB is an equilateral. Okay. So, Z1 is a complex number. Z2 we haven't done vectors yet, right? That's why. Okay, that's probably why. I was just going to say, I don't feel like I've taught vectors yet. Okay, good time to start about a little bit about it right now, so don't stress. Let's write that as well. Don't forget vectors. So that was meant to be today, wasn't it? Vectors, that's okay. Complex. What's that? Where is it? Close that. Okay, so vectors are not that hard in complex numbers. Actually, I'll teach it pretty well, but look at this, and it kind of will make sense. If I've got a vector, for those who understand vectors, if I've got a vector, I can multiply it by something, and it just makes it, if the number is greater than 1, we'll make it larger. But it won't change its direction. That's thank you. If I multiply by a number that's smaller than 1, but greater than 0, so that means it's positive still, it obviously reduces it. Now, yeah, making sense to you? Yeah, but the others, because of your physics and stuff, I'm guessing this makes sense. Okay, so that's a vector, right? If I multiply this number by 3, you can assume it's just tripled in value. Doesn't that like logically make sense?
Yeah.
Right? If I times it by a half, what's going to happen, you think? Literally shrink in half. If I multiply it by a negative, what happens there? It changes direction. You should remember that. We did a bit of vectors like that. You change direction. If you times by negative, you're just changing its direction. It's going to go the other way. Right? Think about it again. Maria, if I said that was 2 and that was 3, 2 plus 3i, you're going to times it by negative 1. Or isn't everything going to change to negative? So it kind of makes sense why I change direction. Right? Mathematically, again, you guys have probably learned it physically, okay? But mathematically, you can also see it makes sense. Okay, keep going. Then we get to angles, because that's all great. What if I want to move this thing? It's very easy. You times it by cis. So there's your modulus. So all the numbers I was doing there were modulus. So r. If you want to rotate, you multiply it by cis anything. All good? So if I go cis pi on 2, that means rotate it 90 degrees clockwise or anti-clockwise? Anti-clockwise, because that's what we're assuming a positive. So that means if r was 1, if r was 1, so that means I'm not changing the magnitude of it, changing the direction, I'm going to literally rotate this 90 degrees. Done. That's where it is now. That's all you got to do. Make sense? That's it. That's what you need to know. R cis theta is rotation. That's literally what we're going to learn with vectors. And then the rest is just going to be questions, because that's the only way you're going to get good at vectors. The question says, explain why triangle OAB is actually an equilateral. Well, we know that Z2 came from Z1 multiplied by cis 60 degrees. Cis 60 degrees. Right? So what do we now know? We know that Z1 and Z2 have the same magnitude. Do you understand that? Mariette, you sure?
Yeah.
Done. They're the same magnitude because they came from the same thing. You haven't increased it. But what do you also know this angle is? 60 degrees because you moved from Z1, you rotated 60 degrees to get to Z2. So one more time, Z2 is equal to Z1 times cis 60 because of pi on 3, yes. Yeah, because EI theta, EI, just think of it as cis. It's probably easier. I think cis is easier personally, but that's something you have to decide for yourself what's easier. Cis, pi on 3. If that's 60, what do I know about these two angles then? Why? Sorry, what's your reason? Incorrect. What are you trying to say? What's the word? I need to hear a word. Say again? Yeah, so there's a word I think we need. You guys are saying it. Now that's better. Yes, I think that word that you're thinking. No, you can't say that one. Starts with I. That's the word you need to say. You've got to first say it's an isosceles triangle because of the sides are equal, like you're saying. So the base angles must be the same, and because these base angles must be the same, and there's 120 left, whatever, yeah, full mark. Yeah. Easy? And then prove. Now, these are the ones that I guess I just said, but once you understand rotation, there's nothing else I can do, it's just exposure. And now it's just a whole lot of questions. They're going to be weird, just like those proof questions that we saw. I can guide you at the beginning, but you got to expose yourself. That's the only way you're going to get really good at it. So like this one here, Z1 squared plus Z2 squared equals Z1, Z2. I don't know what to do. That's how you got to think about it. It doesn't give you any direction, other than the fact that there was an equilateral triangle. So to you, you just got to do something, and fingers crossed that it works out. Yeah, no, but let's see. I thought so. Okay, let's go again. Selection, lock. Here we go. All right. Oh, I want to rub that out. Let's get this bit. Okay. So I'm going to attempt it as if I don't know the solution and see what I'm thinking, what you're thinking, if it's right, and we're going about it in the right place. Z1 squared. Well, okay, I don't know nothing to do with Z1 squared. So just leave it. Z1 is Z1. Right? Z2, I know, is Z1. Just shift it or rotate it. So like I can do something to that, you know, I can go, okay, Z1 squared plus left-hand side. Left one plus Z2, which is Z1 squared, and then technically cis 120 degrees. Yes, no, maybe. Why did I write cis 120 all of a sudden? Because of De Morey. True? Too fast? Maybe too fast. Go back. Z1 cis 60 degrees squared. That makes sense now? Cis 120. Now, quickly you're going to, am I right to assume this is kind of what you would have done? I hope. Cos 120. Cos 120 you would have got negative half. Sine 120. Sine 120 should give you root 3 on 2. Now what we're hoping for is the right hand side to become the same. Well, then you just proved it. So Z1 squared plus Z1 squared take away Z1 take away negative half becomes z1 squared on 2 plus z1 squared root 3. Well, that's negative half plus 1 is a half. Okay, that's it. I can't see me doing anything else with that, so we would have left that. Then we would have gone up to z1, z2. Right hand side. z1, z2. But again, what's z2 equal to? Once I see z1 squared, I'm like, sweet, I had z1 squared here. It's common. So I'm happy about that so far. Then I'm hoping that cis 60 is literally a half plus root 3 on 2. Give me my 3 marks. That was easy. Sounds good? That's going to be vectors. So it's not so much vector based. It's more algebraic based, but we'll do it. We'll do it anyway, in due course. 5 marks. That's meant to be really hard, by the way. Question 14.
Yeah.
Vectors in complex. Prove a mathematical induction. Love that. 4 marks. Very easy. That just looks like our standard one that we've always done. There was no problem with that. So that was good. Vectors we have done, but we'll have to go back to it again. Is not that hard. Show that AC. How do we find AC? From OA and OC. For those who remember the formula for AC, it's vector AO plus OC. And then pretty straightforward stuff. Yeah, I don't think that's it. But I want you guys to do this. Look, this question right here. It probably at the moment doesn't look familiar to you. But if you go into your integration booklet that I gave you, if you go to the reduction step part, you're going to see this exact question. Completely the same. 11 marks. How lucky were those guys? So exactly the same question. For the last one, for the end of paper, for something that it's meant, you already know is the hardest question, so I'm going to already tell you to do that. And that's just too good, too good. So very straightforward, not hard at all. Induction, I don't know if you guys remember it, but for sine, you're meant to choose it as sine n minus 1 theta and sine, and then use integration by parts, but whatever. So not bad, actually. This is the problem one, because the problem is we all asked NESA if pulleys are going to be in the syllabus. They said no, and they put pulleys in the exam. Nice. But mechanics. But I still teach it because I was teaching from the old syllabus. Anyways, I'm like, oh, this would be good to do. Anyways, so they're lucky, but it's stuffed up big time. All right. Yeah, that was 5 marks as well. Spewing. All right. Let me do this for a second. Let's go back. What are we trying to do? I was trying to do U12 extension to complex. Week 3 maybe. Pascal's triangle. There. Firstly, type 1, multiples in terms of powers. Type 2, powers in terms of multiples. There's 2 types. The one 99.99% of the state get comfortable with is the first one. Because it just kind of, it makes logical sense. Like you go on this, expand this binomial, expand this, equate real, equate imaginary, happy days. Type 1, show cos 4 theta equals this. I've just written a whole bunch of crap. So it's not any, what I'm just trying to show is these are multiples in terms of powers. These are powers in terms of multiples. But it will never be like this. It will obviously be more like this. It'll say type 1. I'll send this document. Show cos 4 theta equals 8 cos to the power of 4 minus 8 cos squared plus 1. Can you see how that's multiples in terms of powers? For this one, these are the steps. Apply De Morey, apply binomial, equate real and imaginary, according to the question. We're comfortable with this one? So we have something like this. Blah, blah, blah. Just tell me when something doesn't make sense. Cos by De Morey's, this by binomial, equate real, it will look something like this. Equate imaginary. If you wanted to make it all in terms of causes, you change your sine squares to that, blah, blah, blah. Type 2. Type 2 look like this. Power in terms of multiples. Can we see that? What you need for that one is this, which usually is going to be asked as a proof, like in the HSC, you just saw part 1. So that means, you know what, just me talking quickly. If they just gave type 2, then your exam is going to be type 1. Your HSC will be type 1. That's good, right? But we don't know, but it just usually it's like that. Type 1, type 2, type 1, type 2. Usually. Anyways, we're going to continue. Type 2. So usually they'll give you this to prove. They just gave it with e's. I'm leaving it as z's. Same thing. Zn plus z negative n is equal to 2 cos n, or Zn minus z negative n is equal to 2 I sine. Here's the proof. Z is cis theta. What happens to the two sines? They'll cross out because that's going to be negative sign, and that's going to be positive sign. You'll end up with 2 cos. If you do the exact same but subtract, your causes will subtract, but your sines will add. Sounds good? And then because you wanted power of 6 for cos, what you do is you get z plus 1 on z, or you get 1, just, yeah, because n is 1. N is 1 right here. And you go power of 6. Power of 6. Are you lost, Anouk? You look lost. So let's start. One sec. So that if we've got, let's take this as given for a second. Are you confused at that? Oh no, that bit was fine. Yeah, so we'll take that as given. Then the question said, we don't know what it said to prove right now, but let's just say we knew it was something like this, and then this had to be multiples. Multiples. Yep. So if it's multiples, that means I know this right-hand side. What is the n in front of the theta? 1. So I know that it's going to be like this to the power of 6, which means what's this n? The left-hand side now here. Also 1, right? Because didn't you just say n is 1 here? That gets confusing because later on when we're going to use this, the n is going to be something else. But n is always going to be 1 for the first one. So then you're going to have z plus technically 1 on z. I like to write them like this instead of using negative index laws, but up to you in your math, to the power of 6. What happens now is you'll get 2 to the 6 cos 6 theta equals z6 plus 6z5 1 on z plus 15z4 1 on z squared 20 z cubed. Yeah, of course it's just binomials. This plus 15. Anouk, have I lost you again? No. No, so this is fine. 6z 1 on z5 plus 1 on z6. Then you group this with this. z6 plus 1 on z6. Yes? You sure? Plus 6 z4 plus this one here. So it should be Z4. I'm just going to factorize the 6 out. 1 on Z4. Plus, do the same thing with 15. It should be Z squared plus 1 on Z squared when you simplify. Plus 20. I'm not grouping 5 because Z and 5 will cancel out to give you 4. And then what's Z6 plus 1 on Z6? According to this formula. Z6. Yeah, 2 cos 6 theta. So that becomes 2 cos 6 theta plus 6. 2 cos plus 15. 2 cos plus 20. We'll have to review it again, I think, next week. But that's all you have to do. Like, just, it's not meant to be harder than the other one, but because of the ends, and I think that's where you're going wrong, I think, because of the ends, most students are confused about this. But the idea is the first n is always going to be 1. Because you're always going to be finding this, which is a power. So this n is always going to have a 1 in front of it. I'm probably going to be fast. I'll emphasize it again next week. So next week we'll do this. We'll do vectors and theory of complex. Give me a second. I know you guys don't want to do your speed test.